My name is Jeremy Feaster. I've been at the lab for almost 7 years, which is kind of hard to believe. I've worked in PLS and physical life sciences and the material science division. And so I've been under the great just advisorship of Sarah Baker. And so it's been a fun ride. I actually have been working on a few different LDRDs since I came here as a postdoc in 2018. I actually was part of a LDRD ER and then also two SIs that were working really on using carbon to be able to create new types of materials, whether it's from CO2 or waste carbon. And so really kind of learning a lot more about that, learning a lot more in terms of designing reactors using 3D printing and advanced manufacturing to develop a lot of these different systems, and then also to start to try to scale a lot of these processes to go from the bench scale all the way up to something that is meaningful to an industry partner. So all of those things were great experiences. They really set us up very well to have a lot of experience to then be able to apply for the LDRD disruptive research projects. And for that particular call in 2022, we had a kind of a really cool idea at the time. It's very high risk, high reward. We were really interested in hey, can we take air, the air that we're breathing, and be able to turn that into fertilizer? And the idea of that was just, if that's possible, what could that mean for farmers in Central Valley? What could that mean for communities all over the world? If we could be able to find a new way to be able to produce a fertilizer, to be able to specifically be able to produce ammonia from air, from water, particularly using, renewable electricity. So that's been what we've been working on for the last couple of years. It's been fun. It's been a fun ride. I'm really, really blessed to have an amazing team to work with. We've been working on this whole process of being able to develop these reactors that can, be able to take in air, be able to actually activate them using electrochemistry, and then be able to make things like nitrates that we can then be able to reduce. I think when we started talking with farmers, it was very interesting because we were, we kind of came in very like, oh, we have this technology. Can't this be something that's helpful? They were like, yeah, that sounds great. But what we really need is water. And so literally we kind of were like, well, okay, so how can we help you? And then, an hour later, we've learned a lot about the water shortages and a lot of the pain points around water availability for a lot of farming communities. And so we kind of took that as an opportunity for us to pivot a little bit. So we actually kind of started to not only pursue converting air into fertilizer, but also how do we actually take wastewater and then try to see if we can be able to recover a lot of the waste fertilizer from those sources to then be able to return clean drinking water, which a lot of these communities don't have. They have to source from outside. A lot of the fertilizer that they apply to the crops or in these different types of farming communities ends up in the water tables. They end up just polluting the water sources, and then you end up with water that you can't drink. And so we kind of really pivoted a little bit of our attention to, can we take wastewater, return clean water, and then also recover that waste and then turn it back into fertilizer? And so that's been kind of the whole other direction that we've started working on. And that really just started from a couple conversations with some farmers that they, we kind of joked with them like, y'all are the ones with PhDs in farming. Y'all have been doing this for generations, like teach us, And I think having that mentality of that we're working together to try to achieve something, and that we can learn something from the communities that we're serving in the same way that we can teach them more of the technical science that we've been working on, I think just allows for a much more harmonious collaboration and hopefully something that can lead to something that's meaningful.